Hello and welcome to the Online College of Coding video tutorial series. This is video 1 of the series on creating Squirty Squid at intermediate level using Unity and the C# programming language. In this video, we'll be looking at getting our art assets into Unity and creating a playable character. Before starting this video, it's recommended but not essential that you've worked your way through the beginner level Squirty Squid project. So if you're ready, let's get started. So after starting Unity, we need to create a new project. The first thing we need to do is give it a name. In this case, we're going to call it Squirty Squid Intermediate. And then we need to tell it where we want to save it to. You can save it either to your D drive or your H drive. And then we need to select whether or not we're creating a 3D or a 2D game. We're going to be creating a 2D game in this instance, so select 2D. Then click on Create Project. So with our blank project created, we want to organize it by creating 4 new folders down here underneath Assets. So by right-clicking here on Assets and going Create Folder, create 4 new folders called Prefabs, Scenes, Scripts, and Textures. In the Prefabs folder is where we store objects that are reused and created, like bullets and enemies and walls. So in this folder we're going to be storing things like our obstacles or the enemies that we will be dodging. The Scenes folder is where we store each of the levels that we'll be creating in our game, and for this example we'll only be having 1 level. The Scripts folder is where each of the files that we create that have got computer code in them for creating our game will be stored. And the Textures folder is where all of the graphics and art are stored. Because this is a 2D game, those graphics are called sprites. So, to get our graphics or art assets into our game, we need to go to the course website, and down here where it says Required Art Assets, if you click on each one, you can save them to somewhere sensible, like your D drive or your H drive, so that you can locate them again in a second. And once you've downloaded all of your art assets, select them within My Computer and drag them over into your Textures folder so that you've got all of your art sitting in one place. And now select your background image from the Textures folder and drag it up into your main scene, and using the inspector set the transform position to being 0, 0, 0 and set the scale to being 2.5 in the X and Y axes. Now we want to add our player by dragging and dropping it into the scene just like we did with our background. And for its transform position, set it to -2, 0 and -2. Now remember that for our player to have physical attributes like gravity, we have to add a component. The component is going to be a rigid body 2D. So if you start typing rigid body, we want this one here. Click on that and that adds that component to this game asset. And so if you press the triangle play button from our control panel up here, this will test our game, and you should see the squid falling as it adheres to our virtual gravity that exists in our game environment. Now to start controlling our player, we need to create our first C# script. So select our scripts folder, and here we need to right click, click Create, C# script, and give it a name called Player with a capital P. Now double click on this new script to open it up in MonoDevelop so that we can start editing it to add our own code. You'll recognize this script as the same blank script you get each time you create a new script within Unity. The first thing we're going to do is arrange our parentheses, so once again they make some sort of logical open and close for each of our functions. And then in here on line 6 we're going to declare 2 new variables. The first variable that we've declared is called jump force. It stores the force applied to the player when we jump. It is of the vector2 type variable. And a vector2 stores 2 values, the x and y values. We're not going to be using any x for our jump. We're going to be using 300 as our value for our y force. The second variable we added is called rigid body. It is of type rigid body 2D. This is creating a reference within C# to the rigid body 2D game component that we added earlier. Next, we want to add a single line of code to our start function. And what this line of code does is when the player script first starts, it goes and gets the exact values of this rigid body 2D game component and assigns those values to this newly created rigid body variable that we declared just up here. Now we want to combine these variables and this rigid body component here together by adding some lines of code into our update function. We're going to include an if statement that will check if the player has pressed the spacebar. So if we examine this addition to our update function, we can see that first of all we've got our if statement. If this is true, so in other words, if it has received an input of the spacebar, which is assigned to the get key up, then it will do these two things here. The first thing it does is it sets the velocity of our rigid body back to 0, and that basically just means that it's only going to be adding our jump force each time, not our jump force plus any additional velocity that was already on the player when it received the input of the spacebar. And then the second thing it does is it adds the value of jump force, which we've declared up here, of 300, and adds that as a force to our rigid body. The last thing in our update function that it's doing is calling this new function. Now the reason that it's red is because we haven't added this function yet. So we're going to go ahead and add that now. This new function called rotate to movement direction uses some fancy mathematics including vector 3's and this quaternion to create a virtual illusion of forward movement. It then uses this to rotate the player in the direction of that movement, and this occurs once every frame because it's part of the update function. Rather than trying to type in this big long line of code, I would recommend going to the associated tutorial document and simply copy and pasting this line of code. Now if we return to Unity, that script won't actually work yet until we apply it to our game. We do that by adding it as a component to our player object. So selecting our player script here and our player object from the hierarchy, we get our player script and drag it over to here into the inspector, so we've now added our player script. We can test this is now working by clicking on play, and now when we press space, our player will jump and rotate in the direction of which we want it to be moving. So now we've got a playable character, it's time to start adding our obstacles to our game. In this case, we're going to be using some anemones as the obstacles that we're dodging. So if you go to your textures folder, drag your anemone up and your anemone down into your scene. And now if you roll your middle mouse wheel backwards and zoom out a little bit, we're going to modify the transform positions for our up and down anemone objects. So selecting our anemone down, the ideal position for this is going to be 13, 5, and 0. And our anemone up is going to be 13, -6, and 0. Now that our objects are within our scene, we want to join them together into a pair. We're going to do this by creating, over in our hierarchy, an empty object. We're going to call that empty object anemone pair. So right click on it and rename it. And so now to have the anemone up and down work together as a single object, in the hierarchy we get them and drag them onto the anemone pair, and you'll see they become children of this anemone pair object. Next thing we need to do is ensure our anemone pair object is set to 0, 0, 0 for its position. So do that in the inspector. Then we want to add a rigid body 2D component to this. So add component, start typing in rigid body and select the rigid body 2D. And then in here, very importantly, we need to tick the is kinematic box. What this will do is prevent these obstacles from being affected by gravity. Everything else about it being a physical object will work. And the last thing we want to do to this anemone pair object is add a box which will detect if the player has avoided these objects and jumped through the middle. We're going to do that by adding a box collider. So add a component, start typing box, and select box collider 2D. And in the inspector we want to change the offset and size values. For the offset, set it to 14.5 and negative 0.5, and set the size to being 0.5 and 7. And you can see that's created this green box collider here, and that will be used to detect if the player has jumped through the center of the obstacles. And now that we've got our obstacle, we need a way of moving it across our scene. This will give the illusion that our player is moving through the water. So we need to create a new script. So go to your scripts folder, right click, create a new C# script, and call it obstacle. Double click on your script. So in our blank script called obstacle, quickly modifying our parentheses, we're going to add a new variable on line 6, and we're going to add a line of code to our start function. To copy these lines of code, you can pause this video once they're completed, or you can refer to the associated tutorial documentation and simply copy and paste these lines of code if you'd like to. The variable declared on line 6 creates a new vector 2 called velocity. It is assigned a value of -4 on the x-axis, which means it will have a negative velocity of 4, and this value of -4 can be modified within the inspector to get the desired speed correct. The start function, which runs once when the game object is first created, then assigns this velocity variable to the rigid body 2D with the value of the velocity variable that was declared up here. So save your completed script and return to Unity. And so to make the obstacle script now work, we need to apply it to our anemone pair object. So select the script and drag it onto the anemone pair in the inspector. Now you can test your game, and our single obstacle will now scroll across the screen. Now we need to create a new anemone obstacle every few seconds. So to do that, we're going to create a prefab. This is an object which we can create and destroy over and over. To do that, we get our anemone pair from our hierarchy, we click and hold and drag it onto our prefabs folder. And this will create this new anemone pair prefab, which consists of the objects that we had up in our hierarchy. Before we move on, we now need to get our original anemone pair object and delete it from the hierarchy. So select it here and press delete. And we now need a new script to generate or instantiate this newly created prefab. We're going to call this script generate, and in this new script we're going to declare a new variable, we're going to add a line to our start function, and we're going to create our own new function entirely. In our generate script, on line 6 we've declared a new variable. The variable is of type GameObject, which is a Unity variable, and its name is anemone. Then in the start function we use invoke repeating. This is like setting up something to be used in the update function, but instead of being called once every frame, we can have more control over the frequency that function will be called. In this case, we'll be calling the create obstacle function with a delay of 1 second between each time this call is repeated, and a delay of 1.5 seconds between each of these method calls. Then within our create obstacle function, we use the statement instantiate. This generates a new prefab in our scene, in this case our anemone pair game object. And by using a new vector 3, we can generate each prefab with a random Y value to create a variation in position for each new obstacle. Once again, either pause this video so that you can replicate the code from the screen, or refer to the associated tutorial documents and copy and paste the code from within those. So save your completed script and return to Unity. Now, to make this script work like the others, we need to apply it to a game object that exists within our scene. This is going to need to be done a little bit differently though, because our prefab doesn't exist in the scene. To do that, we need to create an empty game object. This empty game object we're going to call scripts. And then to get our generate script to start creating our prefabs, we need to apply that to our scripts game object by dragging it onto our scripts object. Now we need to link our game object of an enemy, which is currently sitting here as blank. The anemones that we are creating are going to be our prefabs. So we select them from here and drag those up into here. So now our anemone pair will be the game object that is instantiated by our generate script. So, time to test your code. If you click on the play button up the top, you should see the obstacles being generated every 1.5 seconds at different heights. So, well done to this point, you've completed part 1 of this tutorial. From here, as you can see, we need to make our player be able to die if they hit the anemone, and to score points if they manage to jump through.